Today we are starting Unit 2, and we're going to start off Unit 2 with some quadratic applications. Now, application is just word problems. So, quadratic word problems. So, quadratic and quadratic. Okay, so problem number 1 is that suppose that a stone is thrown upward with an initial velocity of 88 feet per second, which is 60 miles per hour, and is released 8 feet above the ground. Its height, h in feet, after t seconds, is multiply the quadratic equation. H of t equals negative 16t squared plus 88t plus 8. And part A asks us to graph and label the window on the axis of the graph. So I'm going to show you how to graph this on the calculator using both the 84 as well as the Inspire. So we're going to start off with the 84, and when I switch over to the Elmo, you won't be able to see what's on the screen if you are watching the video. But just listen, and we'll get through it. Okay, so the first thing I want to do is go ahead and clear the memory on these calculators that we were all on the same starting place. So to clear the memory on an 83 or 84. So what we're doing, doesn't matter if you have an 83 or an 84, the buttons are the same. So to clear the memory, you need to hit the second button, and it's this blue button right here. So second, then the plus sign, then 7, 1, 2. So second, plus sign, 7, 1, 2. And after you've hit that sequence of buttons, you'll see this message on your screen that says RAM cleared. So our random access memory has been cleared. Now the next thing we're going to do is we are going to type in that quadratic equation. So to type in the quadratic equation, you have to hit the y equals button. And the y equals button is this top left button. Now, I'm telling you these steps as if you've never used this calculator before. So if you feel like I'm talking down to you, please don't feel that way. I just want to make sure some people have never used these calculators before, and these are foreign to you. So it's hard to locate these buttons when you're using them for the first time. Okay, so now, the y equals button. We hit the y equals button. It was the top left corner. So hit y equals. And this is where you're going to type in your equation. So our equation on the handout is negative 16t squared. So first of all, the negative button is right below the number 3. So type in the negative, type in 16. Now your handout has a t squared, t for time. But on the calculators, just use x. So the x button is right beside that green alpha key. So if you notice it has a bunch of variables on it, that first variable is x. So type that button by the green alpha key. And after the x, well, this needs to be squared. So you need to hit the x squared button. And the x squared button is right here, and it's diagonal from the 7. So it's on the left edge and diagonal from the 7. And after the square, we need to type in plus 88. And instead of the t, what do I have to put? X, and the X button is right there by the green alpha key. And then we have plus 8. Now if I hit the graph button, the graph button is the top right button. So this button right here is graph. If I hit the graph button, I know I should be seeing a parabola. And because of the negative 16, should this parabola be opening upward or downward? Downward. So if it's opening downward, I can kind of see the left arm here and the right arm here. But can I see the maximum up here in quadrant 1? No. So what we'll have to do is change the window. And to change the window settings, you'll hit this button right here. So top left button, well, it's second from the left, right there beside y equals. Hit window. And these are the factory default settings. X min, X max means my x-axis is going from negative 10 to positive 10. And X scale, where it says X scale is 1, X scale is what the x-axis is counting by. So our x-axis is counting by 1. So 1, 2, 3, 4, 5. Now it's the y-axis that we need to change. Right now, the y values are going from -10 to +10. But was 10 high enough for us to see that top point? No. So we need to kind of just guess and check. So what do you have a guess for the maximum? 50. So let me type in 50 right there. So change the y max from 10 to 50. Then y scale is what the y-axis is counting by. So my y-axis is counting by 1. And if I hit the graph button, top right button, when we changed it to 50, can you see the maximum? No, so 50 wasn't high enough. So go back to window. And we tried 50. What's another number we could try? 150. Let's try that. So type in 150 for y max. Hit the graph button, top right button. Now can you see that maximum? Yes, so it's just guess and check. So guess one number. If you can't see it, try something different. So you might have to try more than one time, or maybe even more than twice. So it may take you several attempts. Now, what we need to know in order to graph this, we need to know what is the x-intercept and what is that maximum. So to find the x-intercepts, we are going to use the calc feature. So that fourth button at the very top, it says to trace, but right above it, it says calc. So I want you to do second trace. So the second button followed by that trace button for calc. And to find the x-intercepts, what is another word for x-intercepts? 0. So we want option number 2 to find the 0. Now on your screen it says left bound and it's asking you a question. So what it wants you to do is to mark the left boundary of your parabola. Now on your parabola you should see an X somewhere. And we will be moving that X using these left and right arrow keys. So if you don't see the X, you might just have to hit those arrows until you find it. And you see this X right here? There's the X. So I need to make this X be on the left side of this x-intercept. So I need to use that left arrow key to bring mine down. And I want to make sure that it's on the left side of the x-intercept. And then once you move that cursor to the left side of your x-intercept, hit enter. Now it will ask you for the right boundary. So move it to the right until that X is on the right side of the x-intercept. So right now, here's where my X is located, and it's on the right side of that x-intercept. So I'm going to hit enter. And when it asks you to guess, hit enter again. And that guess will be down here at the bottom of the screen. So that x-intercept is estimated to be at approximately -0.1. So -0.10 is that x-intercept. Now to find the vertex, again we'll do second trace. And if I want that vertex is at the top, so is it the minimum or is it the maximum? Maximum, so we need option 4 this time. Now again, it will ask you for the left boundary, so you need to move that X so that it's on the left side of your vertex. And you try to get it as close as you can, but notice my X, the cursor, is on the left side of the vertex, then hit enter. Then we need to move it to the right side. So make sure you move that X to the right side of the vertex, hit enter. When it asks you to guess, hit enter again. And that vertex, it looks like the X value is 2.75, and the Y value is all the way up to what? 129. Now one more thing we need to know is this x-intercept down here. So again, we'll do second trace. And for x-intercept, we need option 2 to find that 0. And it will ask you for the left boundary. So I need to move this cursor to the left side of that x-intercept. Hit enter. And then move that cursor to the right side of the x-intercept. Hit enter. When I ask you to guess, hit enter one more time. And what does the calculator estimate for that x-intercept? What is this x value approximately? 5.6. Now the y value, it says 1e negative 11. What does that mean? Yeah, that's scientific notation. This means 1 times 10 to the negative 11th power. And that number is so small that we approximate it to be 0. Okay, now that we have those critical points, we're going to use those critical points to make our graph. And then I'll show you how to use the Inspire calculator. Okay, so the x-intercept. The first one was about negative 0.10. And the other one was approximately 5.60. So those are the two x-intercepts we calculated from the calculator. And we found the vertex. The vertex was negative 2.75. And the y value was 129 on that vertex. And really, there's one more piece of information I need, and that information would be the y-intercept. And what would be the y-intercept for that graph? If I put a 0 here and a 0 here, the y-intercept is 8. So using those points, let's make our parabola. And for the x-axis, I see that my x-intercept goes from negative 0.1 to 5.6. But our vertex, oh, that wasn't negative 2.75. What was that? Yeah, that was supposed to be a positive 2.75. I don't know where that negative came from. Sorry about that. Okay, so my x-intercept need to go from negative 0.1 to 5.6. We're going to have negative 1 over here. And my x-axis needs to go a little bit beyond 5.6, so it needs to go all the way up to 6. And then our y-intercept is at 8, but actually our y-axis needs to go beyond that, because the vertex, what's the maximum the y values go up to? 129. So do I want to count by 1? No. So your x and y axis will always be still the same. Here, it's probably the fastest thing to do is just count by 50. So here would be 50, 100, and 150. And then plot those points. So our x-intercepts are at negative 0.1, which is right there by the origin, 5.6, and our y-intercept is at 8. And the vertex is at 2 3/4, all the way up to 129. And since the A value is negative, it's going to open downward. Now, typically with quadratics, we put the arrow showing it would keep going downward. But is that the case for this problem? No, because will it go below the ground? Okay, now before we answer those remaining questions, let me show you how you would put this into the Inspire. And when you're putting this into the Inspire, you'll need to go to a graph page. If there's something already there, doc B will clear it. So doc B will clear it. And then go back to the graph page and type in our function. Now I'll go more quickly because you're more familiar with this one. We have negative 16 instead of t, it needs to be x. Was it plus 88x or 88t? Plus 8. So negative 16x squared plus 88x plus 8. And when I hit enter, can I see the maximum? No, but that's really not a problem. I can go to menu, and then I can trace it. So menu, trace, and I want to trace the graph, so option 1. And it's similar to the 84s in that I have this little x, and then I can move this x. The nice thing about the Inspire is as I move it, and again, you'll use the left and right arrows just like what we did on the 84s. But the nice thing is once you trace the graph, when you get to an important point, it will label it for you. So there's one of my x-intercepts, approximately negative 0.1, 0. Remember, this is scientific notation. This number's so small, it's approximately 0. If I keep going, even though, oh, I missed one, here's another one. There's my y-intercept at 0.8. And if I keep following it upward, oh, that's not it. One more time. There it is. Now I know I'm at the very top because it popped up the word maximum. So our maximum is at 2.75, 129. Then I can follow it back down to find that final x-intercept. When it comes to graphing these, the Inspires are a lot more user-friendly, but not everybody has an Inspire at home. So make sure you know how to use both calculators. And that second x-intercept was about 5.6. Again, this is scientific notation, and this is so small, it's basically 0. Okay. Now, answering the questions about this graph. After how many seconds does the stone reach a maximum height? Well, here's the maximum height up here. How many seconds did it take to reach that maximum height? Yeah, right here, 2.75 seconds. And then we have the second part, find the height. Well, at 2.75 seconds, what was that height? What was it? 129 feet. So that question had two parts to make sure you have two answers. They wanted to know how many seconds to get to the maximum and what was the height at the maximum. And then for part C, how high in feet is a stone after 1.5 seconds? Well, 1.5, I would have to estimate.
104?
Yeah, I don't want to have to estimate, so I'm going to use a calculator. And if I find 1.5 seconds, on the Inspire, there it is. At 1.5 seconds, what was the feet? 104. So 104 feet. Now, what if you don't have an Inspire at home to answer that? Let me show you how you would do that on the 84. Yes. So on the 84, just like we did earlier, you need to do second trace. So second trace. And this time, we're just going to do value. And down here, it says that our x value was how many seconds? 1.5. So when x was 1.5 seconds, the height is over here, which is what? 104. So that's how you would do it on the 84. Second trace and then value. Okay, then part D, after how many seconds does the stone reach the ground? So looking at my diagram, right here's where it left. It started at an initial height of 8 feet, flew up in the air, what goes up must come back down. So right here's where it hit the ground, and how many seconds did that take? Yeah, approximately 5.6. And put the unit in seconds. So 5.6 seconds approximately. And then the last part, part E, after how many seconds does the stone reach a height of 120 feet, 50 feet, and 106 feet? So those are three separate questions. And if they're talking about feet, they're talking about the Y value. So they want to know, when is the Y value 120? When is the Y value 50? When is the Y value 106? Well, you could trace the graph if you wanted to. That first Y value we're looking for was 120 feet. So there's 104. There's 115. So at 115, it's 1.8 seconds. And at 122, it's 2.1. So I would have to estimate that. I know that 120 would fall between those two y values. So I know my answer needs to be somewhere between 2.1 and 1.8. So what would you estimate that to be? What's that? 2. 2. Sounds good. So approximately 2 seconds. Now if you put 2 seconds, your answer is only half correct. And it's not because we rounded, that's because you only have half the answer. And why is this only half the answer? It has 2 sides to it. It's going to reach 120 on its way up, but after it goes to 129, what's going to happen? It's going to come back down. So most of these will have 2 answers. We need the answer for the way up and then falling back down. So we've got the answer for when it's on its way up. Now we need to find the answer for when it's on its way down. Let's see, so there's 124 feet, there's 117. So my answer needs to be between 3.6 seconds and 3.3. What would you estimate it to be? 3.5. 3.5. And the next estimate is for 50 feet. So similar process. Now do you find 50 feet? So we're going to keep going down. There's 95.4, there's 80, 61.8, and 40.6. So 50 feet is going to be between 40.6 and 61.8. So my answer needs to be somewhere between 4.8 and 5.1. So what would your estimate be? What is it?
Yeah.
At 5?
0.5. That's what I got.
Are you looking at the left side?
Yeah.
Because I'm doing this one
Oh,
over
you're doing it
here.
right.
This one needs to be between 5.1 and 61.8. So it needs to be between 4.8 and 5.1. So what would be our estimate? 5. And now we need the second one. Again, we're looking for 50 feet. So 50 feet would be between 55 and 33. So those seconds are 0.3 and 0.6. Then you said the estimate would be what? 0.5. Okay, I want you to do that next one. Find the 2 estimates for 106 feet. So about how many seconds does it take to reach 106 feet? Let's see, 106 is going to be between 104 and 115. So that would be between 1.5 and 1.8. So what would your estimate be there? 1.8, 1.5. Yeah, we could say it's about 1.6. And then we need one more estimate. And taking it on its way down. Let's see, there's 108, there's 95.4, so I know 106 will be between those two. So my answer needs to be between 4.2 and 3.9. So what would that answer be? 4. 4? So that's really just introducing you to your calculator. Okay, now, a word problem for you. It says that among two rectangles with perimeters of 400 feet, find the dimensions of the one with the maximum area, and find the maximum area. So the first thing they talk about is perimeter. And what figure are we talking about? A rectangle. Now they ask us for two things. They ask us first for the dimensions. So they're asking us for the dimensions of the rectangle. What are they asking us to find here? Length and width. So they want us to find the length and width. And then they also want us to find the maximum area. So on my rectangle, let me label the length. Let me label the width. And that first sentence talks about the perimeter. What is the perimeter formula for a rectangle? Yes, perimeter means add all the sides together. So we have 2 lengths and 2 widths. So 2L plus 2W equals perimeter. But they didn't tell us what the perimeter was. What is the perimeter? 400. So for P, substitute in a 400. Now keep that equation by itself for a little bit. We'll come back to it in a second. So that was the first sentence. 2L plus 2W equals 400. Now, then they said find the dimensions of the one with the maximum what? Area. Well, how do you calculate area for a rectangle? Length times width. So length times width equals area. Now this is really what we need to solve here. We're looking to find that maximum area. Now in order to do that, if I just multiply L and W, that gives me LW. Can I do anything with that? No, we need to have these have the same variable. So what we'll have to do over here to our perimeter equation is either solve for L or solve for W. So let's go ahead and solve for L. And what would be the first step to get the L by itself? Subtract 2W to both sides. So 2L equals negative 2W plus 400. And the last step to get L by itself. Divide by 2. So everything gets divided by 2. And that gives us the length is equal to negative W plus 200. Now, once you have L solved for, we're going to take what L equals, and we are going to substitute it into that area formula. So instead of L, I need to substitute in negative W plus 200. And since that's a binomial, group it in parentheses. So after length, this is length times width equals area. What should I do next? Distribute. So distribute the W. So it's W times negative W. Negative W squared plus 200 times W is 200 W. Now, in order to solve these, we're looking for the maximum. So if they're looking for the maximum, they're actually asking you to find the vertex. So we have a formula we used back in Algebra 1, but it's been a while. So to find the vertex of a parabola, the vertex is going to be an ordered pair. And to find the x value of the vertex is going to be negative b over 2a. So to find the x value of the vertex, it's negative b over 2a. And that's when your equation is in standard form, ax squared plus bx plus c. So negative b over 2 times a. Now to find the y value, you just substitute into the equation. So whatever answer you got for x, you substitute that into the equation to find the maximum. So it's just f of negative b over 2a. Now, if I drew a picture of this, negative w squared plus 200w, because of this negative, which way does it open? Down, so it's going to be something like this. Now, this is a very, very rough sketch. So what we're looking for right here, we're looking for this maximum area, delta A max. And this number down here is not x. If we solve this equation, it would actually be w. So the first thing I need to do is figure out what the x value or w value would be. So I need to use this formula right here. So to find the width, we need to use the formula for the vertex, which is negative b over 2a. So from our equation, what do I put for negative b? If this is positive 200, this needs to be negative 200. And this would be 2 times what is a? Negative 1. So negative 200 divided by negative 2 would be what? Positive 100, and what would the measurement be? What units are they using? Feet. So the width is 100 feet. What else did they ask me to find? The length. So to find the length, I could use this formula down here. The length would be negative, and what do I substitute for the width? 100 plus 200. So what is the length? 100, and what would the units be? Feet. So we have the dimensions. What else do they ask us for? The maximum area. So if I want the maximum area, well, how do you find area? Length times width. So this would be 100 times 100, which would be 10,000. And what would the units be for the area? Square feet. Feet times feet would be feet squared. So make sure you have all of those answers. You have to have the length, you have to have the width, and you have to have the maximum area. Now that was the easier way to find the maximum area. The other way would be to substitute the negative b over 2a into the equation. And for negative b over 2a, we got 100. So what I would do, I would find negative 100 squared plus 200 times 100, and when you actually do the math, it would be 10,000. So you could substitute back into the equation, or you can just do length times width. And most of you would probably just do length times width. Next problem. For this one, it says that a long rectangular sheet of metal that is 10 inches wide is to be made into a gutter by turning up equal sides of equal length perpendicular to the sheet. Find the length that must be turned up to produce a gutter with maximum cross-sectional area. Okay, so we have a piece of metal that is 10 inches wide. And we need to take that piece of metal and we're going to turn up the edges to make a gutter. Now they said that for these edges, it needs to be equal length. So let's see. So this piece of the metal is turned up, and this piece of the metal is turned up, and now this piece in the middle makes the gutter to catch the rain off the side of the building. Now, do I know how much has been turned up? No, so what could I call that? X. So this would be X, this would be X, and what would this piece be in the middle? 10 is for the entire length of all of it. So it's not going to be 10. It would be 10 minus those two X pieces that got turned up. 10 minus 2X. Now again, we're still trying to find the maximum area. So again, how do you find area? Length times width equals area. So what do I put for the length? 10 minus 2x. What do I put for the width? X. What do I do next? Distribute. So distribute that x, what does that give us? 10x minus 2x squared equals area. Now to find that vertex, again, if they're asking you about the maximum, you need to locate the vertex. To locate the vertex, it's negative b over 2a for the x value. So that means our equation has to be in standard form. Is this equation in standard form? No, the negative 2x squared should go out front. The positive 10x should go at the back. So now if I do x equals negative b over 2a, what would I put for negative b? Negative 10, and this would be 2 times negative 2. So that would be negative 10 over negative 4. And what does that simplify to? 5/2. Now, when it comes to measurements, if I were trying to help my husband build something and he asked me how much he needed to cut off, would he be happy if I said you need to cut off 5/2 of a foot? No. So with these measurements, usually improper fractions are okay, but with these measurements, go ahead and convert to decimal form. So what would that be in decimal form? 2.5 inches. So x is 10.5 inches. Now what did they ask me to find? Find the what? Length that must be turned up. Well, is x the length that needs to be turned up? Yes. So technically I'm finished with that problem. But once I have the length, how would I find this piece right here? Substitute. Do 10 minus 2 times 2.5. So what would this piece be right here? 5 inches. We have 5 inches, 2.5 inches. And if they ask me for that maximum cross-sectional area, and cross-sectional area would just be this piece. Like if you had a 3D object, it would just be the end of the board. The cross-sectional area goes all the way across the board. But if you think about like when you're going to Lowe's and you get a 4x4, the part that they scan, the barcode can be on that bottom part. So they're just talking about that edge.
So it's between the 2 edges.
Yeah, it's going to be the area between those two sides, between the part that was turned up and the part that's not turned up. Okay, so again, to find the area is still length times width. So this would be 5 times 2.5, and what would that maximum area be?
12.5 square inches.
Yes, 12.5 square inches. So again, these two pieces were additional information just that we were asked to find both dimensions as well as that maximum area. Okay, moving on to these last problems. We're only going to do problems 4 and 5, but we want to make sure that we have some time to look at your homework. Not homework, but your test. So it says to find the vertex, x-intercept, y-intercept, and graph each of the following. So it first asks us for the vertex. So to find the vertex, it's negative b over 2a, and it's f of negative b over 2a. So once you get the x value, substitute it into the equation to get the y value. So get the x value first, substitute it in to get the y value. So to get the x value on the vertex, we need to do negative b over 2a. So for negative b, b is the value in front of x. Well, do you see x? No. So what is the b value here? 0. And this would be 2 times what is a? negative 2, and this would be 0. So the vertex, the x value is 0. To find the y value, you substitute in the 0. So for the y value, right here for x, I replace it with 0, so it's negative 2 times 0 squared plus 8. And when you simplify that, what do you get? 8. So once you have the x value, substitute it into the equation to get the y value. So there's the vertex, is at 0, 8. Now after the vertex, they wanted us to find the x-intercept. If I want the x-intercept, how do I change it to a different color? If I want the x-intercept, what does that mean about the y value? The y value has to equal 0. So if you want the x-intercept, put in a 0 for y. So when I do that, that would be 0 equals negative 2x squared plus 8. Solve for x. What would I do? Subtract 8 to both sides. So that gives me negative 8 equals negative 2x squared. What's next? Divide both sides by negative 2. So that gives us 4 equals x squared. And how do I get rid of the square? Square root. And the square root of 4 is? Plus or minus 2. Got to be careful, right? Okay, so we got the x-intercept, so now I have to find the y-intercept. And for the y-intercept, that means your x value has to equal 0. So if I write it out, I need to put a 0 right here. So this would be y equals negative 2 times 0 squared plus 8. And what would that y-intercept be? 8. So once you have all of those, then you can figure out how you need to scale your x and y axis. So for my x and y axis, notice that my x-intercepts go from negative 2 to positive 2. From negative 2 to positive 2. You can fill up the number line if you want to. I'm just trying to do this quickly. And the y-intercept is what? 8. And the y-intercept is the same as what? The vertex. Now you don't have to label every single sig mark, but you need to label it enough to where I can see what you counted by. So what's your scale? And once you have all of that marked, go ahead and plot those points. So the vertex is at 0, 8 right here. That is also the y-intercept. And we have x-intercept at negative 2 and positive 2. And when I connect my points, notice the a value is negative. So the a value is negative, does it open up or down? Down. So my parabola needs to point down. Needs to go through negative 2. 8 is going to be the top. And then come back down through the second x-intercept. Okay, we're not going to do all of these. Our last problem will be problem number 5 because it's a little bit different. So we're still doing the same thing. The first thing we need to do is find the vertex. And first thing we need to do is find negative b over 2a. Once we find that, substitute it into the equation to find the y value. So what do I put for negative b? Yes, negative 3. And this would be 2 times 1, which would be negative 3/2. And for graphing purposes, change this to a decimal, so this would be negative 1.5. And once you have x, substitute it into the equation to find the y value. So right here for this x, put a negative 3/2 squared plus 3 times negative 3/2 minus 7. And I'll do this by hand. What's negative 3 half squared? 9/4. Square the top, square the bottom. What's 3 times negative 3 halves? 3 times 3? Yeah, so minus 9 halves. Minus 7. I want common denominator, so I'll use a common denominator of 4. So this would be 9/4 minus, instead of 9 halves, how many fourths would that be? 18. And instead of 7, how many fourths would that be? 28. So 9 minus 18 would be negative 9. What's negative 9 minus 28? Negative 37 over 4. And for graphing purposes, I really need that in decimal form. And what would that be in decimal form?
Negative 9.25.
Negative 9.25. So that means my vertex is negative 1.5, negative 9.25. So right now, the y-axis has to go down to at least negative 9.25. Now, this one continues, so let's find the x-intercept. So if you want the x-intercept, that means the y value equals what? 0. So when I do that, that would be 0 equals x squared plus 3x minus 7. So if you want the x-intercept, put in a 0 for the y. Now, that's a quadratic equation. You can solve quadratic equations by completing a square, by factoring, by quadratic formula. Factoring is usually the more common one, but can I find two numbers that multiply to negative 7 and add to positive 3? No, so if factoring won't work, quadratic formula it is. So x equals negative b plus or minus square root b squared minus 4ac divided by 2a. Did you think you never have to use that one again? Here it is. What do I put for negative b? Negative 3 plus or minus the square root. What do I put for b? So this would be 3 squared minus 4. What do I put for a? 1. What do I put for c? Negative 7. All over 2a. So this would be 2 times 1. A little bit of simplifying, so this would be negative 3 plus or minus. We'll figure out what that value is in just a second. And 2 times 1 is 2. What's 3 squared? 9. And if I multiply these three values, what's negative 4 times 1 times negative 7? Positive 28. What's 9 plus 28? 37. Now, for graphing, can I really say my x-intercepts are negative 3 plus square root of 37 over 2? No. This one we really need to put in a calculator. So, negative 3 plus the square root of 37 over 2. And that's approximately what? 1.5. So the x-intercept is approximately 1.5. And the second x-intercept, I'm going to highlight that problem, hit enter, so I don't have to retype everything. Delete the plus, change it to a minus. And that second x-intercept is approximately what? Negative 4.5. And one more thing I need to find is the y-intercept. If I want the y-intercept, what do I put for x? So if I put a 0 here and a 0 here, what would be our y-intercept? Negative 7. Okay, using all of that information, now we need to figure out how do we need to scale our graph. Well, our x-intercept went from what to what? Negative 4.5 to 1.5. And I need to make sure that will include the vertex. Yeah, the vertex is going to be between those two. So I know that my x-axis needs to go to at least negative 5. have -4.5 and 1.5. Our y-intercept is -7. But is -7 going to cut it? No, because if you look at our vertex, has to go down to what y value? -9.25. Now, I don't have enough room to count by one. I guess I could, I think. Yeah, here's -10, -8, -6, -4, -2. Now the remaining point, what was the y-intercept? -7. And our vertex was at -1.5, -9.25. And connect those points. And looking at the A value, is the A value positive or negative? Positive. So if the A value is positive, which way should this parabola open? Need to open upwards. So point up, go through the x-intercept, hit the minimum, go through the y-intercept, and hit that final x-intercept.